So I had a conversation with some folks probably about 4 or 5 weeks ago, and we were just talking about their reliability patterns, any of the failures that they've experienced, and how they recover from some of those incidents. And someone piped up and said, "I've got a bunch of load balancers that can take care of everything." And while partially true, reliability is not just about using a bunch of load balancers. It's a lot more than that. And so I'm here to talk a little bit more about the context behind how you achieve reliability, things to think about, and ways you can probably start forming that strategy altogether. My name is Marino Wijay. I am a solutions engineer at a company called Commodore. We focus on Kubernetes operations, reliability, and troubleshooting. I'm also an organizer for a conference called KubeHuddle that is out in Toronto and was first run in Edinburgh, Scotland. So similar to a KCD, similar vibes, very Kubernetes oriented. And I am also a CNCF and Civo Cloud ambassador as well. Now, the idea of load balancing, what is it? It's really about having a pool of resources that can share the load at any given time for situations where you might scale or for situations where you might have failures. So you have these services on the back end or servers on the back end, and there's something of a proxy or a system that front ends it and load balances those requests. When something fails, well, it doesn't matter to that end user. Things are still functional. But let's be real, this is just not reliability. This is not all it is. There's so much more. There's so much more context, and we're not just talking about network load balancers. So I popped out a post on LinkedIn, and I just really talked about the context of reliability and what it really means. And one of my good friends, Daniel Finneran, I'm sorry if it's a little too small, he strongly believes that load balancing is the answer. And in a lot of ways it actually is, because it's just the context by which it's applied, the layer at which it's applied, and the technology space you're using to apply that concept. And it's also funny because he invented a technology called KubeVip, which behaves as a load balancer for Kubernetes, for the control plane, as well as if you're using it for service of type load balancer. Now, I want to ask you a few questions, and that's why I was kind of saving these towards the actual presentation. So go scan that QR code. I promise it's not going to take you anywhere nefarious or funny. It's literally a survey that I want you all to just participate in, because I want to know what you think about reliability, or what comes up when you think about reliability. And don't worry, that QR code is still available to you. So what does reliability mean to you? You're going to be given the option to just throw in a bunch of words, and we're going to see a word cloud pop up. And I'd actually like to see what that means. Trusting, okay. Available, trust. Confidence, no downtime. Maintainability stays up. Smoke detectors installed. Happy clients, uptime, graceful failure, stability, unwavering. Keep them coming. I've got another one right afterwards. Money, okay, interesting. That's a good point of view, right? I think that reliability translates to what happens to a business and how it cannot function. So available and trust, that's interesting. Reliability has ties to availability and trust. Okay, that's something to think about for the next time I deliver this talk. All right, so what is reliability? I've got a bunch of different criteria that I'm going to run through, and I'm going to kind of give you stories, things that I've encountered through the past that led me to believe that there are better ways to achieve reliability. So a long time ago, when I was that sysadmin where I was supporting clients and users, imaging laptops and servers and deploying Exchange and all that fun stuff, and I would still get requests from developers saying, hey, I need access to a Windows operating system because I want to deploy my .NET application. Great, okay, let me call up my server person, and it'll take probably about 3 months. And then it shows up, and it'll take another month before it's all imaged and patched and it's ready to go. But that greatly affected developer velocity. One of the challenges, though, is that you bought this massive box that only one person gets to use. And so that application they built maybe consumes 10%. What about the other 90%? We've got wastage. And that led to a revolution of, let's use virtualization. Let's leverage virtualization to pack as many workloads as we possibly can. Now, why I bring up right-sizing workloads and your infrastructure is because if you over-right-size your workloads, if you oversubscribe them, if any of you have worked in the storage space, by the way, you might have oversubscribed your LUNs, right, for your virtual machines or your hardware. And then you might run into a situation where you basically hit capacity for storage because you've oversubscribed. And that's an incorrect approach of right-sizing, because now that's going to lead to something of a reliability issue. If you run out of storage, there is no I/O. So the consideration here is that what is in place at the moment that helps you right-size your workloads today and gives you a better way to, win at Tetris or workload Tetris. So there's another element around reliability, and it's around policies. It's not just about, hey, I can set up a firewall policy that blocks traffic. It's really about the guardrails that you're missing. For example, if you're running Kubernetes at scale, have you locked down your nodes so that no one has root access to be able to jump in, spin up workloads, maybe cause a denial of service attack? Right, that's one form of a guardrail that you probably might want to implement. Maybe you consider using something like the Talos operating system, which is completely, supremely locked down and is just entirely focused on Kubernetes. So there aren't any other daemons or binaries running on that operating system. But the guardrails piece is interesting because I remember way back when I would install Windows operating systems. Remember when people would ask for admin access? Local admin access, what does that actually mean? That means, hey, I have God mode access to this server now, and I can install whatever the heck I want. That's actually an anti-pattern today. We don't do that anymore. We try to limit end users and what their ability to do for infrastructure, because we don't want them to overrun infrastructure, we don't want them to over-consume resources, and then break infrastructure so that your other applications suffer. Service latency. This is an interesting one because this is dependent on so many different factors. When you have latency that exists in your network or your environments, your systems tend to not respond quickly enough, which tends to possibly affect application performance, which can lead to reliability issues as well. So how do you address that? Well, there are so many observability systems that exist out there that help you understand the telemetry of monoliths, the telemetry of your microservices, the service-to-service interactions, the service calls, and how often they occur. And once you have that information, you have this ability to implement some level of QoS, or quality of service. And this is not just network quality of service, like the stuff where we would implement DSCP and whatnot for our different queues. We're talking about understanding that workloads have different classes of CPU and memory requirements and network requirements, and they need to be classified accordingly so that they get the resources that they require when they're running, and then they don't consume resources when they don't need to. But we can also track that, and we could also track things like when a service fails, do we have a circuit breaker, or do we have an ability to go to a secondary or a copy through, load balancing. So there are ways to reduce service latency by also tuning, right? Now, how many of you have ever worked with a service mesh before? Great. I love this, because service meshes are very much popular today, and they do help with that service latency reduction, because you're able to see the different services that do exist. You're able to do some service discovery, but you're also discerning patterns, communication patterns, request patterns, request failures, and then you get to decide, hey, what's actually going on with this one service that might be breaking everything else. So a long time ago, when we had an issue, let's go back 15 years, I would have MRTG, I would have access to some logging system, some syslog server, I would log into an offending device, and I would have all of these different data sources that I'd have to comb through to find out what an issue is. That's different today, because we have systems that consolidate all of these extremely powerful and knowledgeable data sources, and basically allow us to either decide if we want to create our own prompts to decide what is actually going on or what we're actually looking for. And why this is important is if you're an SRE or a platform engineer, imagine if you are trying to reduce your MTTR for a second, your mean time to repair. One of the biggest challenges is the tooling. You have so many tools to hop into. If you're using Kubernetes, you might be using Lens. If you're using Service Mesh, you might be using Kiali. To try and see what's actually happening. You might be using Wireshark or KubeShark. These are all different data sources, which creates fatigue as well, because you also have to remember all of these logins. And so you also have to think about the cognitive load that happens to a particular individual when they're trying to figure out what's actually going wrong at a given time. That happened to me several times, where the actual resolution of a problem was because I had to hop through a bunch of systems, and it took me 3 hours to solve the problem, where if all of this was consolidated into one platform, boom, maybe 5 minutes. Now, how many of you actually sit there and get scared when you have to click the button for Kubernetes upgrades? Right? Hey, the button's there, just click it, right? What's the worst that could possibly happen? A bunch of CRs break, and then Istio stops working, or Argo CD stops working, or maybe some of your applications break. And it becomes very challenging to track that as well, because APIs deprecate. We know this. Kubernetes even tells us when they release what APIs are deprecating and what you need to look out for in the next iteration, and what you need to plan for and accommodate for. So that's like one form of it. I mean, there's other things to think about as well. If you're using a cloud provider, or if you're managing your own on-premises environment for infrastructure, you probably have to be in lockstep with your providers to determine when they have maintenance going on. If they have to, let's say, take down the entire data center because they're redoing their plumbing for whatever reason. Not that that happens that often. But for situations like that, if you're not in lockstep with them, that leads to reliability concerns, because you cannot be proactive when things fail, unless we talk about the disaster recovery conversation for a second. Because way back in the day, when people had failures, when people had outages, they immediately thought, hey, I've got backups. Let me take those backups and then stand them up at another location. Oh wait, I don't have hardware to do that. I got to buy the hardware now. Now I've got to form the strategy. Okay, so now they've got the hardware. It's all warm. It's ready to go. Now they want to, restore their backups. Oh wait, I didn't test out my backups. Nothing is working. Great. Okay, now we've entered another dimension of replication. So we have a hot site and we have a warm site. We're replicating our data, and we're synchronously doing so. So anytime there's a change in the data, the deltas are transferred over. Great. Oh, shoot, I forgot about the network. I forgot about the policies. Forgot about the fact that if I move everything over, I've got to re-IP everything. And what that actually turned into is, okay, if I'm just spinning up all this capacity, why don't I just make everything live and run at all times? So that's great, but then how do you handle failovers? How do you handle load balancing? And this is where technologies like DNS and global load balancing come into the mix. And we've seen how those technologies have advanced and been iterated upon to just help with the planning of when we have to do an upgrade. Last week I was actually at the CNCF Toronto meetup, and we had Shopify come up and present a few times. So how many of you know the company Shopify? Cool. So there was one particular presentation around how they handle Kubernetes upgrades when they're running Kafka. So they've got Kafka clusters all over the place, and when they have to do an upgrade, what they end up having to do is they have to create the new cluster, point their storage targets, so their PVCs and PVs, to that new cluster, replicate all the data first, and then have a small window for where they actually have the deltas, do the cutover, and then copy over the deltas, which was fascinating but slow, because it takes 15 hours to do something like that. So they came up with a better process. I can't share the details of that because I actually can't remember the details. But they shortened the process from 15 hours to 45 minutes. And that's actually pretty damn shocking. One of the things that they did was they realized if they leveraged a lot of GitOps principles, they'd be able to achieve that. Oops. Okay. So here's an example of a situation of reliability where you have developers working all over the place and building different tools. And I'm sure some of you have seen this image. But we have that one little dependency, and that dependency is interesting because it could be anything. It could be the provider that we live on. We're dependent on that provider to exist tomorrow and not be under some sort of like government regulation all of a sudden. We might be under the situation where, one individual developed this IP for how our application functions, but then they decided that they're going to resign and they haven't documented anything. Now what? I'm sure we've run into that, and that actually leads to the reliability concern of, what are we doing to make sure that our systems don't depend on individuals or people anymore? And that's where we've gone, right? Like YAML has really changed the game, right? Hasn't it? I think, maybe? I don't know. Strategic MTTR reduction, right? That's an interesting one because it's not just about, hey, I'm going to strategically reduce my mean time to recovery. It's thinking about all what I've said and all what I'm going to say afterwards, because we also have to think about the infrastructure. We have to think about how long it's going to take me to provision hardware. And if I'm not provisioning hardware, how long is it going to take me to provision that EC2 instance or Kubernetes cluster? Okay, let me ask you, how long does it take you to spin up an EKS cluster? Be honest. And don't cheat with EKS-CTL. Weeks, right? Okay, is that fair to your business if they say we want to deploy an application that needs to scale, we want to run Pokemon Go at scale? No, right? And so we have to consider, how do we speed up that infrastructure deployment? And so it's not just about sticking to one provider because we see that that's a dependency that creates a reliability concern, but if we spread to other providers, maybe consider some of the smaller tier providers, maybe take some of this on premises all over again, maybe use some of the edge. We have a lot of flexibility. And I think technologies like Kubernetes has enabled that for us. Okay, getting back into service mesh again. So a long time ago, when I was back in the, when I was in the networking world, one of the biggest concerns was around what happens when a service fails. Does our application stop functioning? What happened? Am I running out of time? I have 5 minutes. Okay, I think I'm almost done. I don't know. I can't remember. I've lost track. I made this deck this morning, by the way. I tend to do that. Now, when you think about service failures for a second, one of the cool things about what service mesh really helped with in the Kubernetes space, and now even in outside of the Kubernetes space, like in the bare metal and even virtual machine space, was that it would act as a responder on behalf of the service. The service fails, well, this little thing called the sidecar proxy would go back and tell the rest of these services, hey, I'm down, I'm out, count me out for a bit because I still need y'all to function, but when I'm ready and healthy again, I'll come back and play. And it was a lot more than that because it was also the consideration around if services weren't smart enough to make calls to each other, we could invocate that for them. We could make that call for them through a service mesh. If we wanted to protect the way services talked to each other, we could implement that with the service mesh using some authentication and authorization mechanism. But one of the cool things that service mesh really does is a retry. Our services naturally don't retry themselves or retry calls. And the service mesh can be tuned to do that for us. In fact, API gateways have been doing that for us for a long time, and we just shortened that or made that smaller for the case of services. Now that you have all this data, now that you have all of these considerations, it's really about a consolidated platform, right? Bringing it all together, tying it into a singular system. Now, way back when I was in my ops days, I didn't have that. I'd log into a bunch of Cisco routers, ASAs, I'd hop into some cloud services, and everything would be all in parts. And today we have platforms that consolidate through APIs, through webhooks, through various integrations, through the fact that operators can live in our clusters and our VMs as agents and just report on a variety of metrics and telemetry data. So I've got a couple more questions for you. I want to know a little bit about how many incidents y'all have had. And don't lie to me. I know you've had more than 0, but if any of you say 0, I will find out and we'll have a conversation. 11 or more. We need to have a conversation, whoever said 11 or more. we'll just call them generic incidents for now. It doesn't matter, right? Because any incident, small or big, could lead to something catastrophic down the line, right, if not addressed quickly enough. All right. Give you all another 10 more seconds. All right. So, the one last thing I'll say is DNS. DNS has been one of those very critical pieces. By the way, I decided not to use the generic haiku picture that is out there on the internet. I actually took a picture of that in Toronto and decided to no, this was like a last minute thing. I'm like, wait, I have that picture. I could probably put this together. Anyways, DNS is always going to be a problem in a lot of ways and cause reliability issues. And we still see this today. Like, it's 2024, and we've still seen DNS-related issues. I also want to turn your attention to the Kubernetes era for a second, because look, we're not just at let's spin up a Kubernetes cluster, log in, deploy Nginx, and hello world, and be on our way. No, we're way past that. We're past that conversation of what version are we picking. We actually have multiple versions that exist today. We're using different tools, different applications, different systems that all integrate and have different moving parts. And it goes back to what I said earlier. If Kubernetes changes, the version goes to 1.31, how many of your sub-applications break, right? And that's what we all have to keep track of. So I've got one more question for you, and I think we're pretty much rolled and done. But I want to know, like, how do you feel after an outage? Like, how do you emotionally feel? What happens? What's going through your mind? Sad, okay. Yeah. Unsafe. New job. I'm waiting for the resume generating event one. Frustrated, like crap, okay. Learn, failure. This is all good because guess what? When incidents occur, we learn from them and we get better. We document them, we know how to work around those situations again. We know how to prevent them from ever occurring again. So, having said that, there are platforms that exist that allow us to consolidate all this beautiful, different pieces of information, all these systems, from Argo all the way to Kubernetes to that system that shows up called PagerDuty or Slack or whatever. And it's beautiful because guess what? These are the systems we mess around with today. Like, how many of you are using Slack today? Right, everyone, or 99% of you are using Slack. Maybe some of you are using Teams, I'm sorry. But the reality is, with these systems, they tell us information. They act as like chatbots for us at times and tell us when something goes wrong. For us today, it's Commodore. So I am not going to show you a demo because I'm out of time. Actually, I never planned to show you a demo. But I will say, Commodore is sitting on the rooftop somewhere. Go check them out. Go have a conversation about Kubernetes and your reliability challenges, and they will help you out. And if you have any questions as well about anything about my past, around what I've done, around disaster recovery, come find me. Thank you very much for your time.